Good morning, all of you. I am Tanushri Dalai from Civil Engineering branch, and today I am going to teach you your Theory 2 paper, which name is Structural Design 2. So it is based on basically on steel design. Okay. So in the last class, we discussed about the various kinds of loads which acting on a steel structure. So like your dead load, imposed load, wind load, snow load, earthquake loads and special loads. So today we will discuss about the special consideration of steel design. So we all know that for a design purpose we need some criteria by which we can design any kind of structure. So there are some limitations also there, some kinds of terms and conditions also there. So these are generally known as considerations of the design. So in case of steel design, you will get a lot of considerations according to your code, which is your IS 800-2007. Okay. So the general consideration you can get from the code. So now some special consideration also we have to take for the design purpose. So for the steel design, there are 4 kinds of special consideration are there. So these are size and shape. Second one is buckling. Third one is minimum thickness, and fourth one is connection design. So let's come to the size and shape. So in this consideration, you will get the steel is manufactured in steel mills and is available in certain shapes and size. As I am told in the previous class, all the rolled steel sections which we will design a structure, a steel structure, can easily available in an individual section in the mills. Okay, with a specific shapes and size. Okay, so hence the member of the steel structure should be designed to consist of any of the available sections. Okay, or a combination of them. That means if in the mill the I section is available in a proper flange wave section, then we can say the whole I section is available in the mill for the design purpose of a steel structure. Also we can get 3 individual section of I sections, like here the flange section is one individual section, the wave section is one individual section, and another flange also a one individual section. So by combining these 3 individual section in a unit, we can form a I section also. So you can also buy a proper I section from the mill. Also you can buy 3 individual section, and after that by combining these 3 section you can get a I section. So like that you have to clear about the what kind of size and shape you need. So as per the design requirement, you need to clear about the what kind of dimension you want. So as per your criteria of design, you put the shapes or you put the sections on that structure. Okay. So as an example, if we take a beam section, may be a standard I section or may consist of built 3 sections as shown in the figure. So as I told in before, like here is a total whole I section. So now just see this I section. This is not a proper I section. This is not a single section. It is a combination of 3 individual single sections, and it is connected by welded joint over here so that it forms a section as I section. And the second section also, it is also a combination of 3 individual sections by which we can get a whole I section, and it is combined or jointed by bolting connection. Okay. So next one is your buckling. So you all know that the buckling is occur in case of long span members. So we normally consider the compressive member always subjected to the buckling. Okay. So the permissible load per unit area in steel is much higher as compared to the permissible value of concrete. So we know that as compared to concrete, the steel have more permissible load per unit area. Okay. So therefore, the same load, the cross-sectional area of a steel member is smaller. So as compared to concrete, if we consider the steel section, so for the same kind of loading condition, the steel area should be smaller as compared to concrete. Okay, because the steel having more permissible load criteria. Okay, so as the member in the steel structure are more slender, so slender means it is the effective length by radius of gyration, which is always in the column section. Okay, so the compression member in steel structure are liable to buckling. So in case of beams, there are chances of lateral buckling, which creates special problem. So as the steel member consists of a number of thin plates, the stability of each part is to be considered. Okay, so you have to consider the buckling case in case of column. That means your steel column, we have to take into the consideration the buckling part. So you have to first consider the span of the column section. After that, it is liable or it is good for the loading condition or not. You have to clear about that. Okay. So next one is your minimum thickness. Okay. Any kind of rolled steel section or any kind of member of steel, each of the member have its specific minimum thickness. So it is also a special kind of consideration in the steel structure. So the corrosion needs special consideration in steel design. Okay. So steel is a alloy of iron. So its chances of corrosion in case of steel design. So if very thin section are used in the steel design, a small amount of corrosion may result into a large percentage reduction in the effective area. Correct? That means if the corrosion will occur in a steel, then the steel may have lose its strength capacity. Okay, so it is reduction of effective area. It reduce the area of the effective in that case. So hence we have to design practice specify minimum thickness to be used in structural member. For the members directly exposed to weather, the following minimum thickness is to be used. So we will discuss the what kind of thickness is considered in the special consideration in the next class. So today this much. Thank you so much.